in 2 dimension. Okay, so we can have various kind of problems related to this. So first we can take this kind of example. Suppose we have a rod, horizontal rod, suppose like this, and a ring is sliding on this rod, and another object is hanging from here, and there is a pulley here. This pulley is like this, fixed. This pulley is fixed. Okay, this is the pulley, and this is movable. This is moving with velocity u, suppose, and we have to find velocity v of this object, and given find relation between these two velocities when the angle is theta. Find relation between u and v when the theta is given, when u and v only solo. It is suppose it is find relation between u and v with theta also. Okay, so how do we relate it? So you can see that in this example, if you see, what we can write is, we will write here also, we'll write constant relation. So if we write this as y, this as x, from here to here, from the fixed point we have taken a distance y, here to here x, and this is z. So we can write z square equal to x square plus y square. We can write this. But you can see that if the ring moves on this rod, the x will change, the z will also change, but a y is fixed distance. So if you differentiate it with respect to time, the differentiation of y is going to be 0. So z, we will write 2z dz by dt, and the x we will write 2x dx by dt. We have seen this is not with respect to x, so we cannot write only 2x. This is with respect to t, so we have to apply the chain rule. We have to write like this, and this will be 0. So dz by dt, the rate of change of z, the rate of increase of z or decrease of z, whatever. So that we can write as x by z dx by dt. Okay, so now what we can do is, see, dx by dt, the rate of change of dx by dt, the rate of change of x, that is what, minus u. You can see this will be minus u, because whatever is the u, that is the negative of rate of change of x. The x is this distance, so u is, and x by z will be what, cos theta. You can see this is x and this is z, so that is cos theta. So cos theta and minus u. So what you can write is minus u cos theta. So this is the dz by dt, means the z is decreasing at this rate. The z is decreasing at this rate. Okay, so if z is decreasing at this rate, by the same amount, this lower object would be moving downward. If this is a and this is v, this object, since the string length is fixed, so at whatever rate the upper string is decreasing in length, the lower string will increase with the same value. So dz by dz will be, the dz by dt will be equal to v. So you can write cos theta, and if you just equate the magnitude part, because this is what, minus plus is just for indicative, this is just for indicative of increasing or decreasing. So you can write the magnitude, if you relate magnitudes, the v will be u cos theta. Why? Because v is equal to dz by dt and u cos theta that we have related with that for this problem. So this, what is this alternate method? In this method, what we can see is, if we see the length of the string, at whatever rate the length of the string is decreasing, that we can write, see, this is u is in this direction, so component of u along the string, if you write, so this is u cos theta. So this is what, this is rate of decrease of length of string. Okay, so what does it mean? Means this is the u is given, the this component of u along the length we have found. This is component of u along the length. This is component of u along length. Okay, this is component of u along length. Okay, so this is what? This is at this rate the u will decrease. Now on the other side, since string length is fixed, so at whatever rate string is decreasing, by the same rate string should increase on the other side. So that should be equal to v. So you can directly also write like this. So you can take components of velocity along the string and then you can equate the velocities on two sides. One side is this, other side is this. So you can write like this.